Okay, so this video we're going to talk about the Pythagorean Theorem and using it to find out how far away hurricanes are, or to use it to find the distance between plots on or points on a plot of a hurricane. Okay, so let's say we have a hurricane here, and we're about here, us, hurricane. We'll put a frowny face like, grrr, we'll give it fangs. There we go. It's a mean hurricane. Okay, so this hurricane is coming towards us, and we want to know how far away it is. So what we're going to do is we're going to use the Pythagorean Theorem to figure that out. Okay, so we said that Pythagorean Theorem in the last video, and also just as a review from geometry, is this, right? We have our hypotenuse, which is the longest side, and that's C. We have our other two sides, and we said that we could figure out the hypotenuse by taking the squares of the stuff. So we said, okay, well, a squared plus b squared equals c squared. So then we just plug everything in and solve for c. Well, that's all fine and good, except that looking at the map, we don't have a triangle, we just have 2 points, right? Okay, that's what it looks like. But actually, we can turn this into points. I mean, we could turn this into a triangle. So we know, so the hurricane is going, let me draw it with a line so it'll be prettier. The hurricane is going from this bottom right point to us, which is the top left point, and it's going this way, right? But we can take that and we can say, well, really, that there are 2 parts to that line. There's the part of it that's going straight west, and then there's the part of it that's going north. So really, it's got components, right? It's got that one going west, and then it's got, let me make a different color, we have this part going north. So if we look at it like that, then all of a sudden we kind of do have a Pythagorean theorem type of thing going on, right? Because this is our west component right here. This is our north component. So, and this is our distance. So we can use those two, and those become our sides for our Pythagorean theorem. So we can go, okay, well, north squared plus west squared equals distance squared. But then we go, yeah, but how do we know how far we went to the west, and how do we know how far we went to the north? Because we don't have those sides. All we have is a coordinate points. So this coordinate point, looking at the map, is 85 west, 20 north. So we would go 20 north, 85 west. And the coordinate up here, and this is not exact, this is actually a little bit south of Galveston, but okay, I'm just going to use it. I'm just going to round it so it'll be easier. This is actually 29 north and 95 west. So, okay, so notice that each of these then, and it's a little tricky to see on the map, each of these has a north part, and each of them has a west part. So those north parts and west parts are what we're going to use to find the actual side. So like just looking at the west, and I'm going to draw it down here. We start here, and we end up here, right? So looking at the west component of the first one is 85. So we start at 85 west, we end up at 95 west. So then we went from 85 to 95, that's 10, right? So this is just, if you look at it, if you want to put it like formula form, this is your west 2, your second west component, this is your west 1. So to find your west, you just subtract them. So this would be, let me move this because I think there's a watermark that goes there. So I'm going to say, okay, well, my west coordinate is the second one minus the first one. And it doesn't matter if this comes out negative, because when we square it, it's going to go back positive anyway, so the sign on this doesn't matter. So if we look at it that way, west 2 is 95, west 1 is 85, 95 minus 85 equals 10. So that will be our west point, or our west coordinate. For the north, we do the same thing. We go, okay, well, our north is going to be the second one minus the first one. Well, in this case, our second one is 29. Our first one is 20. So this is 9. So then we plug that in. We go, okay, well, d squared equals n squared plus w squared. So in this case, that's going to be 9 squared plus 10 squared, right? So 9 squared is 81. 10 squared is 100. So distance squared equals 181. And we're almost finished, but not quite. We need the d to be by itself. We don't want d squared. So to get rid of the square, we square root both sides. And if we do that, we end up with d equals 13.45. Okay. That's the whole process. That's the whole thing we're going to do. But there's one thing to remember. We started with degrees, right? It was 29 degrees north, 95 degrees west. 20 degrees north, 85 degrees west. So when we calculate this all, our distance is 13.45, but that's not miles or anything like that. That's degrees. So our units, we started with degrees. We didn't do anything to convert. So this is distance in degrees. Okay, so that's a little bit weird, and we're going to convert that to miles. There's a conversion factor, but that's going to be the next video. So we're going to practice again with another one. Okay, so we're going to practice again. This time we'll pretend like we're in New Orleans. So our coordinates at New Orleans are 30 degrees north, 90 degrees west. And let's say there's a storm way out here at 16 north, 52 west. And again, we want to know how far it is away. Really, what we want to know is when it's going to get here. But to do that, we start out with how far away is it. So, okay, so we're going to do the same thing. We need our west coordinate, and then we need our north coordinate. So we need our west, we need our north, and we're going to find our distance. So to find our west, so west equals second west minus first west. In this case, our second west is 90 degrees because it's 90 west. Our first west was 52. So 90 minus 50 is 40, and this is 52, so I'm going to say that's 38. Okay, our north coordinate, we do the same thing. We do the second north point minus the first north point. So our second north is 30. Our first north is 16. And 30 minus 16 is 14. Okay, so we have our two sides. Now we just have to plug this into our triangle. So we have 38 is our bottom side. 14 is our vertical side. We're looking for our distance. So we're going to plug that into our a squared plus b squared equals c squared. And we're going to say, okay, our distance squared is 38 squared plus 14 squared. Not going to lie, I'm going to cheat and put this in a calculator. Not really cheat, I'm just going to put this in a calculator because I could probably eventually do it in my head, but that would take a lot longer, and yeah. Okay, so I pulled out my phone because I always have that handy. So 38 squared is 1,444. 14 squared is 196. If I add those together, I get d squared equals 1640. And then I want d by itself, so I square root this. And I get d equals... Okay, when I took the square root of that, I get d equals 40.4969. We don't need to be that exact. I would round it off to like 2 or 3 decimal points. In this case, if I rounded it to 2, it would be 50. Because, you know, this would round to a 7, that would make this go up, that would make this go up. So I'm just going to call it 40.5. So this is 40.5. And remember that our unit was degrees. So this is 40.5 degrees. Okay, so distance as a degree doesn't really make any sense. Like, you wouldn't tell your mom, hey, I'm going to my friend's house, she lives 2 degrees away. We need it in miles. So the next video we're going to do is we're going to convert that. But this is our basic how to apply the Pythagorean theorem and get distance.